Here's a parallel circuit with three different sized resistors. Okay. Now each one of these resistors is connected to the 10-volt source. So this top node here, this entire top node, everything here is 10 volts. Okay. So if we wanted to look at the voltage drop across R1, it's 10 volts. The voltage drop across R2 is 10 volts. The voltage drop across R5 is 10 volts. So we can use Ohm's law and find the current I1 through the resistor R1, which is going to be, so I1 is going to be our 10 volts divided by the resistance of R1, which is simply 1 ohm. So the current therefore is going to be 10 amperes. Okay, remember in Blackboard we need 3 significant digits, so it'd be 10.0 amperes. The current I2, which is the current flowing through the resistor R2, is going to be the 10 volts divided by the 2 ohms of resistor R2, which is going to be 5 amperes. So it's 5.00 amperes. The current through R5 is going to be the 10 volts divided by the 5 ohms. So it's going to be 2.00 amperes. Okay. So the current flowing in this section right here, all the way through here, down to here, all of this down here, all of this highlighted right now is 2 amps. So there's 2 amperes of current flowing through that. The current flowing through here is 5 amperes. Okay. So the current flowing in this section right here and in this section here is the 5 amps plus the 2 amps, which means there's 7 amperes of current flowing through these 2 sections of wire. Okay. The current flowing through here is 10 amperes, and so the current flowing through here is 17 amperes. So there's 17 amperes flowing this way. When we get to this point, 7 amps go to the right, 7 amperes go to the right, and then the 10 amperes go through R1. So notice here that R1 is the smallest resistance, and yet it has the largest current, right? So the resistors take the path of least resistance, but all paths have some resistance. All right, so this path has 1 ohm resistance, this path has 2 ohms resistance, and this path has 5 ohms resistance. So all paths have some resistance. So what we get is more current through the least resistance and the smallest current of 2 amperes through the resistor of highest resistance. Alright, so which one of these is using the most power? Well, remember that power in a resistor is the voltage across the resistor times the current. So that's 10 volts times 10 amps which is equal to 100 watts. Okay. Or we can also say it's equal to I squared times R. Well, I is 10, so it'd be 10 squared. 10 amperes squared times R, which is 1, which is also 100 watts. Okay, now remember, if this is going in Blackboard, we need a period. 100 period, and then the watts for our 3 significant digits. Okay. This resistor is 2 ohms. All right, so its power is I squared, which is 5 squared times R. Okay, I squared R. So that's 5 squared times 2, which is 25 times 2, which of course is 50 watts. So it'd be 50.0 watts. So this resistor R2 is twice the size of the resistor R1. It has the same voltage but only half the current, and so therefore it's using half the wattage. Similarly, R5 is 5 ohms, so that I squared R, all right, so we have 2 amperes squared times the 5 ohms means it's using 20 watts. So it'd be 20.0 watts. Okay, so it's using 1/5 of the wattage that R1 is using. Okay. But how much power is our source providing? Well, our source, the power, is the sum of all the powers. So we have 100 watts. So power total here is 100 watts for P1, 50 watts for P2, and 20 watts for P5, the power through the resistor R5, which is 170 watts. 170 period watts. Or we can say it's the total current times the total voltage, which would be 10 volts times 17 amperes, which is again 170 period watts. Okay. So the total power is the power being dissipated in each resistor, which is the voltage supplied times the total current being fed. So what is our resistance of the entire circuit? Okay, so we see up here at the top I have the equation for resistors in parallel, right? So this is the resistance, this is for resistors in parallel. And so the way you would punch this into your calculator is you would take your resistor 1, so you'd take 1 and then you would hit the -1. Most calculators have a -1 button. So you'd hit 1 to the -1 plus 2 to the -1 plus, and then 3 to the -1. Okay. And then you would hit the equals button and then hit the -1 button again, and that will give you the total current. And notice that the total current, if we look over here, the total current, I calculated it before, is 0.588 ohms. So 0.588 ohms. So that is the total resistance of this circuit. So we could redraw this circuit with our 10 volt supply feeding a single resistor of 0.588 ohms. Okay. Notice that the resistance of this parallel circuit is less than the smallest of all the resistors in parallel. So it's less than the smallest of all the resistors in parallel. So if you do if you're looking at parallel resistors and you calculate your total resistance, double check and make sure that this resistance is smaller than the smallest resistor in your circuit. And if it's not, then you know for sure you've made a mistake.